Welcome to Science Store online classes.
Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome to all of you once again to the physics classes. Dear students, we are talking about the topic nuclei. In that, some of the questions already we have discussed, and today we have reached to the 20th question. Okay, I hope all of you have gone through the previous parts of the videos. If you haven't seen that, just go through it, just go through the questions. Already this classwork will be sent to you, go through it. That is, the next question says that the binding energy per nucleon of deuteron is. Binding energy per nucleon means you are going to write down binding energy per nucleon. That is binding energy per A you are going to write down, isn't it? So binding energy per nucleon, which is equal to how much? That is 1.15 MeV. It is not in terms of joules, in terms of it is EV. Mass defect in AMU is, mass defect in AMU is. So in terms of AMU, mass defect you have to find out. Mass defect, you know that we know that 1 AMU, that is mass, which is equal to how much energy? 931 MeV. No, that is energy. Mass can be converted into energy, isn't it, in terms of converted. So this is not that much necessary for this problem, but I just said that, which is useful. Okay. Now binding energy per nucleon, deuteron means how much nucleons are there? Deuteron means 2 nucleons are there, no? Okay, that is isotope. So deuteron 2 nucleons are there. I can write down binding energy divided by A, which is equal to 1.15 MeV. Now binding energy, I can see energy only I can write down in terms of mass, no? AMU, no? So I have to find out binding energy, that is 1.15 into 2, which is equal to MeV. So how much you are going to get? That is 2.30 you are going to get, right? Or 115, okay, it is 115, okay, 115, okay. See, this 115 means into multiply means, say, I said for make it too easy. So what you have to do, a point, you are bringing point, it is not like that. Multiplying means 1000, 2 times means 2230 it is. So 2.230 it becomes, no? In that way 2 times means. Now MeV is there, you have to write down in terms of AMU. So 931 MeV means 1 AMU. Now some amount of MeV is there, that is 1.115 into 2 MeV means how much AMU? That you have to multiply and divide it by 931.5 MeV. Now what you have to do? 2 into 1.115 MeV is there, divided by 931 MeV is there, 931.5 MeV is there. MeV cancel, so you are going to get in terms of AMU. So how easily you can multiply? Again I said that you multiply, this becomes, or you make it half, okay, then you multiply by 10, all those. So multiplication must be faster. Multiplication must be faster. So you know every formula to apply, you know every things to apply, but you don't know this fast, the fast of multiplication, the fast of division, the fast of numbers, the fast of interchanging the decimals, the fast of interchanging the number of isn't it, the characters, decimals, integers and all means. That will be difficult for you, isn't it? That's why you have to make it fast. So if you multiply this, means that left to you, you are going to get 0.0024, 0.0024, or easily I can make out that this is nothing but 1000, no, this is nearly 1000, this is nearly 2000, okay, 1000 ones are 1000 twos are, so 2 you have to get, again some powers are there, you are going to get that, isn't it? Easily I can get, but nearer answers are there, no, it may be 12 or 24, it may not be, it definitely it is not this, okay, so like that, some, but you can't take the chances here also in the examination also, when you are going to get such, you know, distinguishing or such judging fact, when you do this on your own without any, you are at home, we can't check that you are using calculator or not, your mind says that let's use calculator and we'll do it, but don't listen that, you do on your own. When you do this, you can judge after 5 to 6 problems, such kind of you will do this, you can judge B is the answer because 2 times, otherwise you can't, okay, that is the thing. So answer is B. Go to the next question, which is on the screen, read that and tell me the answer, okay. So now next is the energy equivalent to 1 milligram of matter in MeV is, 1 milligram means, see 1 AMU means how much, 1 AMU means 1.6 into 10 to the power minus 27 kg, which is equal to how much, 931 MeV. Now how much kg is given, kg is not given, milligram is given, no, so that is 1 into 10 to the power minus 3 grams, but you have to write down in kgs because SI unit is kg, and kg if you write down means k into g, k means 10 to the power 3, so into 10 to the power minus 3 you have to put, so balances, no, or kg, gram you have to convert into kg means divided by 1000, no. So that all you were doing in 5th, 7th standard, 8th standard, 9th standard, like that. Now it is not like that. Now logic is, see, kg means already gram is there, you have to convert in terms of kg, k you have written means 10 to the power 3, so it has to balance, so 10 to the power minus 3 you are going to write down, okay. So it comes in terms of k cancels and becomes 10 to the power minus 3 gram only, no, like that. Like that arrangement you should know, okay, it is not like the divide this that, no, nothing, okay. So how much, that is the cross multiplication here, okay, E is equal to mc square, you can do the cross multiplication in that way you can do, okay. So find out the answer for this, you are going to get the answer, okay. So in that way also you can calculate, or else in other ways also, so that is E is equal to mc square, in that way also you can calculate, isn't it. So E is equal to mc square means how much, that is nothing but 1.459 into, so 931 MeV means how much amount of joules, okay. So again that is one method, and also you can go that, see, 931 MeV means how much you have done, that you have done, no, E is equal to mc square, isn't it, that is, this was 1 AMU, that is 1.66 into 10 to the power minus 19, 1 MeV means how much of joules, that is 1.49 into 10 to the power minus 10 joules, 1.49 into 10 to the power minus 10 joules, that you have to remember. Dear students, this you have to remember, that is joules. Now how much joules you are going to get from this, E is equal to mc square, that is the m is nothing but how much, 1 into 10 to the power minus 3 and minus 3 minus 6, c square, that is 3 into 10 to the power 8 whole square, that is nothing but 1 into 10 to the power minus 6 into 9 into 10 to the power 16, so that you are going to get 16 and 6 cancel, so 9 into 10 to the power 10 you are going to get, that is in terms of joules, in terms of joules. Now you have to convert into MeV, this method also you can use, that is nothing but 931 MeV means how much, 1.49 into 10 to the power minus 10 joules, then 9 into 10 to the power 10 joules means how much MeV? So multiply this and divide it by 1.49 also you can do. 1.49 into 10 to the power minus 10, that also you can do. Now 2 to 3 times this problem you have to see, and you have to remember exact way that what you have to make it divided by what you have to multiply. When you convert AMU, when you convert MEV, all those things. Okay, because 3 to 4 times maximum information is there in this problem. Okay, and if you do that means you are going to get this. Okay, so every answer is same now. Every answer is same now. You should not have. Now the speciality of this problem is, whenever the question you will see, you have to see the answer, 4 answers. Now it is a very easiest question. Need not to do anything with the answer because every answer is same, but only changes in powers they have given, right? Only changes in powers they have given. Don't divide anything. Don't waste time for that. Just go and see the powers, 10 to the powers. Okay, and hence you can find out the answer, that is plus. And in terms of MEV you have to give. In terms of MEV you have to give. Okay, already you are writing in MEV itself, right? So MEV will be you are going to get. Okay, M means, see, that is 20. Okay, so in terms of MEV you have to give, so that see the things for this you are going to get 56.25 into 10 to the power 22 MeV. Some amount you are going to get, in terms of EV you are going to get, okay, like that. So this is joule going to cancel because divided by takes place, so MeV will be left. Okay, and now don't write down 10 to the power 6 EV like that. So don't be over smart also. Okay, so this is the easiest problem, but 3 to 4 times you have to go through it so that you will get exact idea what to divide, what to not divide, where to divide, what is the powers, all those things, because very important problem. Go to the next question, that is, which is on the screen. A nucleus ruptures into 2 nuclear parts. A nuclear ruptures into 2 nuclear parts. This divides, which have their velocity ratio equal to 2:1. 2:1. Then the ratio of their nuclear size will be. Now say for example, one nuclei is there. It ruptures into M1 and M2. Now they have given M1 and M2, okay, which have their 2 nuclear parts, which have their velocity is equal to 2:1. Their velocity is equal to 2:1, means their velocity is equal to 2:1. 2 times V1 or 2 times V and 1 time V. Okay, one is 2 times V, one is 1 times V. Now that rupturing mass is directly proportional to what? Not velocity, A1 and A2, atomic mass number, isn't it? That is depends on 2 nuclear parts, ruptures into 2 nuclear parts which are there. That is, that mass, if I say, means okay, is directly proportional to the mass number. I can write down. The mass number you can also write down, that is directly proportional to R, because I want nuclear size is directly proportional to R, isn't it? That is directly proportional to R. So what is the equation for that? A1 and A2, isn't it? Okay, I have to write down A2 here, A1 and A2. Now it is directly proportional to R1 and R2. Then the ratio of their nuclear size, you have to find out. Okay, so what you are going to get? R1 and R2 means A1 and A2, but you know that is M1 is 2 and M2 is 1 time. So substitute and find out the answer. So we know that momentum will be M1 V1 M2 V2, right? So I can write down V2 by V1, which is equal to M1 by M2. But V2 is how much? 1 time. V1 is how much? 2 times V and 1 times V, which is equal to M1 by M2. What is M? M is all directly proportional. A1 by A2, no? We know that R we want to find out. R is equal to R naught directly proportional to A to the power 1 by 3. So I can write down. So that implies I can write down A is directly proportional to R to the power 3. No. So 1 by 2, which is equal to A1 means R to the power 3. A2 means R to the power R2 to the power 3. Okay. So we want R1. R2, which is equal to 1 by 2 to the power 1 by 3, 1 by 3, 1 by 3 if you take 3 you take here means it becomes cube root 1 by 3. So 1 is 2, 2 to the power 1 by 3 you are going to get, 1 is 2, 2 to the power 1 by 3 you are going to get, and go to the next problem which is there on the screen. Go through it and try to find out the answer. Okay, it says that two nucleus are at a separation of 1 Fermi nucleons. Okay, one is neutron or proton or neutron or neutron or proton at the separation of 1 Fermi, that is 10 to the power minus 15. Okay, and have the charge 1.6 into 10 to the power minus 19 coulomb, means it is proton, and the net nuclear force between them is F1 if both are neutrons, F2 if both are protons, and F3 one is proton and another one is neutron. Then which one is the greater force? Now nuclear force is spin dependent. Nuclear force is spin dependent and it is charge independent. They have given here only charge. They have not mentioned about the spin. So the distance will be same. So what I can write down, what I can have an interpretation for this problem. Is it that proton force is more? Is it that proton neutron force is more? Or is it that neutron force is more? No, it is not like that. Nuclear force is charge independent, so that all the forces are remain same or constant. That is what nuclear force is. So the option is B. Go to the next question, that is, if suppose 200 MeV energy is released in the fission of a single uranium 235 nucleus, the number of fission required per second to produce 1 kilowatt power shall be. So released in the fission of nucleus, the number of fission required per second. So what do you mean by power? Power is nothing but work done by time. Work done is nothing but energy by time. Work done is itself is energy. So how you are going to get the total energy? We have written, isn't it? Power is nothing but number of fission per second into energy with respect to time. With respect to times. Now you have to find out some amount of energy I have to generate, some amount of energy I have to generate, so that what is the power I have to generate, that is 1 kilowatt power I have to generate. Then what is the amount, what is the number of nucleons per second fission is required, that is N you have to find out. N itself is number of fission per second. So N, which is equal to P into T divided by E, you are going to get, isn't it? So what is P? P is nothing but 1000, isn't it? 1000. So nucleons per second means that is this. Okay, nucleon per second divided by P by E, so it is 1. So P is nothing but kilowatt. 1000 watt, isn't it? Watt, in terms of watt I am going to write down 1000 watt into the total energy is 200 MeV. 200 MeV means how much? In terms of joules you have to write down. This is not in terms of number of means in terms of, not in terms of MeV. Okay, 200 MeV, how you are going to write down? 200 means 200 into 10 to the power 6 EV. EV you have to cancel, no? That is 1.6 into 10 to the power minus 19 joules you have to multiply. It comes here 1.6 into 10 to the power minus 19. So you will get this, isn't it? So in the denominator you are going to get that. Okay, so total you are going to get, or n is equal to 200 into 1.6 into 10 to the power, okay, you have to multiply, okay, so that you are going to get, the answer is 3.125 into 10 to the power 13, 3.125 into 10 to the power 13. So if you direct apply here in this problem, that is 1000, which is equal to n you have to find out, the energy n you have to find out, and energy will be how much? That is 200 into MeV, that is nothing but, if you multiply you are going to get in terms of joules 10 to the power 6, that is 1.6 into 10 to the power minus 19, because you know that is 1 EV is equal to 1.6 into 10 to the power minus 19 joules. So this much of MeV means how much? Isn't it? Divided by 1 EV. 1 EV means 1.6 into 10 to the power minus 19 joules. So 200 MeV means 200 into 10 to the power 6 EV means how much joules? Okay. So that you have to again carefully you have to go through it. Okay. So then divided by, okay, n into E divided by, you have to find out for 1 second, that is 1, okay, this. So here you have to divide it, here this is multiply, here you have to divide it by 1000 divided by this you have to do, so that simple. So 3.125 into 10 to the power 13 you are going to get. We were talking about the questions in nuclei. So next we are going to, for the 25th question, 1 gram of hydrogen is converted into 0.993 gram of helium. 0.993 gram of helium, that was 1 gram it was, right? In a thermonuclear reaction, the energy released is, so energy released means MeV it is given? No. So no need to worry, direct you can apply this formula, which is equal to mc square. Now see, I will tell you, small metallic pieces are there. You will find out the individual mass. You will compress it, make it together, and it will become a large mass like this. What is the mass? Mass must be same, no? But here what happens? The number of hydrogens were there, it is converted into helium now. But mass is decreased. It should have to be 1 gram. But it is decreased. Why? Because that some mass is utilized as binding energy. Some mass is utilized as binding energy. Now binding energy means what is the mass difference? That is 1 minus 0.993. That is 1000 minus 993 I can write down, no? That is, which is equal to 0.007. 0.007. Now E is equal to 0.007 was gram, that is in terms of kg if you write down, means into 10 to the power minus 3, and C square means 9 into 10 to the power 16. How it is 9 into 10 to the power 16? 3 into 3 into 10 to the power 8 whole square is 16, right? So 9 into 7 you are doing, 9 into 7 is 63, so into 10 to the power 16 was there. Okay, 1, 2, 3, 4, 5, 6, it goes, becomes 10 joules, right? Because 1, 2, 3, here it goes, and here it goes plus 6 here. So minus plus. I hope you know this. Every multiplication and all quickly you should know. So it is not like that always you will waste time for this. You can do this. If you are wasting time for this, means it is a waste. That's why you have to constantly work on this, the multiplications, the arrangement of decimals, all those things quickly you should know. So next we are going to talk about the next question, that is 26. Go through it on the screen, okay, and try to find out the answer. It says that the half-life period of an radium is, that is actually must be 1600, okay. So 1600 years. The fraction of sample of radium that would remain after 6400 years. So just to make it proper, some mistake is there. So it's 1600 and 6400 years. Now half-life, all those means directly n naught, out of n naught, n is there 1 by 2 to the power n, which is equal to 1 by 2 to the power t by t half. That is the equation you have to go. You have to find out n naught is radium 600 years, fraction of sample radium would be, okay. So 640 years, that you have to find out. Now n you have to find out, n which is equal to n naught into 1 by 2 to the power t is nothing but 6400 divided by capital T, that is half life is 1600. It cancels, 16 ones are 16, how many times, that is 16 fours are 4s are, so 16, 2 to the power 4 is 16 into n naught, that is 1 by 16 times, okay. Fraction this asked, that is n by n naught is, they have asked, that is this, okay, that is 1 by 16 times. So this is what about the equations. We were talking about the chapter nuclei. In that almost 26 questions we have discussed. So when I say about the competitive classes, this exams and how to preparation is, refer any one of the material, any one of the standard book, solve more and more questions, and have maintained the consistency in your work, okay. Synopsis once or twice you see, that is enough, okay. And whatever you are question solving, only not only that, you have to revise those questions, that is very important, very important. So for example 50 questions you have solved, after that you have to revise it, that is important. Now again next question we will going to solve, that is decay constant of radium is lambda. Radium is there, that is a radioactive material, and whose decay constant is lambda. By a suitable process its compound radium bromide is obtained. The decay constant of radium bromide will be, the decay constant of radium bromide will be, okay. So the question is asked about decay constant, that is lambda. So now decay constant of a radium lambda by a suitable process, its compound radium bromide, whatever it is, so radium and radium bromide, okay, that is a chemical reaction, so that it becomes radium bromide, right. Now decay constant is depends on the radioactive substance. Here the substance is not changed, it is a compound on radium itself, okay. So the decay constant will be constant, it is a same, the decay constant remains constant for the any of the radioactive material. Go to the next question, okay, that is activity of a radioactive sample is 1.6 curie, that is 1.6 curie, which is equal to, and its half life is 2.5 days. Half life is 2.5 days. Now the activity after 10 days will be activity after 10 days. See, out of n naught, n is there, out of a naught, a is there, which is equal to 1 divided by 2 to the power n, which is equal to 1 divided by t half. This formula you have to remember. N naught, n by n naught, a by a naught is same or equal. Now this I am going to erase, this I am going to take, a by a naught I am going to take, that is a divided by a naught. Now you have to see that the units, whether it is given in same or different at the first. So same you have given, it is need not to change. Okay. Days and days itself is given, so did not to change. So for that you have to find out. So direct substitution, the radioactive sample 1.6 curie, the activity, and its half life is 2.5 days. The activity after 10 days is, the initial activity is 1.6, half life is this much, this is 2 to the power, half life is 2.5 days after 10 days, that is. So a you have to find out, a is equal to 1.6 into 1 divided by 2 to the power 2.1, so it is 100 divided by 25, that is 4, isn't it? So 2 to the power 4. So it was 10 divided by 2.5, one point I will shift here, or multiply by 10, multiply by 10 means that 100 divided by 25, it becomes 25 ones are 25 fours are 2 to the power 4, it will be like this. Okay. So multiplication I am going to tell you, main thing is as shown as formula you will be knowing, my dear students, formula you will be knowing, you know to apply, but you will take time for the multiplication, you will take time to decide the decimals, you will take time to make for the approximations. That approximations will quickly has to come, how it will come. This kind of practices is very much necessary for you. Okay, that square till 1 to somewhere squares you remember, square roots you remember. Okay, square root of 2, square root of 3, square root of 4, square root of 10 till 10, that you have to remember sometimes. These are all while you are doing the questions, you have to write down somewhere, so that you will remember and see that. Okay, like that, this is the thing. Now next, 2 to the power 4 means it is 16, so 116 divided by 16. Okay, so 160 divided by 16, 1.6 is there, that is 16 divided by 160 it becomes, no, that is 10 to the power minus 1. So I can write down, see, this is 16 1 is 16 tens are, so 1 by 10 means 10 to the power minus 1, which is equal to 0.1 curie, like this. This is the option, and we have got 0.1 curie is the answer. Go to the next question, look at the board, okay, and find out the answer. This is a very easy question, Now the activity of a radioactive sample can be increased. The activity of a radioactive sample can be increased. How it can be increased? The activity of a radioactive sample can be increased. Is there any answer? Is there any method to increase the radioactivity? No. It is the spontaneous process. It is the character of the submaterial. You can't say uranium this time you disintegrate rapidly, or next year decrease your half life. No, it is not like that. It is a constant. Activity is a constant. So there is nothing like you can, by heating, by applying pressure, or by applying field, no matter or no method, whatever, you can't change the activity of a radioactive substance. So there is no method to increase the activity of a radioactive sample. So next you are going to talk about 30th question. Okay, in the nuclear reaction, H, and some X value you are going to get, and some proton you are going, positron you are going to get, and after that energy you are going to get. The emitted particle is, so which one, what is that? Now see, X gives, okay, now I will write down Y here, Y gives X plus this much. The atomic number has to balance, mass number has to balance. 0 is there, so here 1, 2, 3, 4, 4 is there, 1, 2, 3, 4, so it must be 4 here, 4 plus 0, 4 plus 0 which is equal to 4, balanced, so it is 4. Now it is 4 means must be alpha particle. Let us see, mass number is 4, such other particles are there or not? Neutrino is not, proton is not, neutron is, directly you can write down. But again you want confirmation, means this atomic number also we will see. Here it is 1, 2, 3 is there, 1, 2, 3. Here 1 is there, plus how much equal to 3? 2 equal to 3. So it is X is equal to this one, isn't it? X is equal to this one. Simple balancing. So that is nothing but alpha particle. Go to the next question and try to find out the answer. Now, the half-life of a radioactive element depends on, half-life of a radioactive substances depends on temperature, pressure, nature of the element, quantity of radioactive material. So what is the formula for half-life? Half-life which is equal to lambda into 0.693 into lambda, isn't it? 0.693 divided by lambda. There is half-life. Now temperature, pressure, nature of the element, quantity of a radioactive material, no? So these are the things. The half-life of a radioactive element is depends on temperature, pressure, nature of the element, quantity of the radioactive material, that is nature of the element. It depends on the nature of the element and does not depends on anything. Okay, so it is depends on decay constant, and decay constant depends on different material. So go to the next question. Graphs are there. The dependence of very important question, it is very important. See, I will tell you binding energy, okay, nuclear forces, okay, at the first, in atoms what we are going to study? In the atom what you are going to study at the first? This isotopes, isobars, isotones, these are things. Then binding energy, then nuclear force, nuclear reactor, okay, about energy sources and binding energy. These are all very important. More than that of the radioactivity, this is very important. These topics you have to, more and more questions you have to solve. Radioactivity is simple, but more weightage you give for that other topics also. And in NCERT textbook, tables are there, go through it. Tables are there, different data is given, that you have to go to. Exactly they will give that in the fourth option. If you have seen means you will be knowing it. If you didn't seen means you have to calculate all those things. That's why. Next, the dependence of binding energy per nucleon Dn on the mass number A is represented by, see, binding energy per nucleon by mass number. How we have written the, in this way you have written, no? For 56 it was I. Where do we have such graph? This one, here, there. No, for the 56 it is very high, no? For the 56, for the iron. These are all not there. So A option is the right option. A option is the right option. So next 33. Mass per nucleon in an ordinary hydrogen atom is. Mass per nucleon in an ordinary hydrogen atom is. That is, so now the mass per nucleon in an ordinary hydrogen atom is. So just go through it.
Don't forget to like our video and subscribe our YouTube channel for all the updates.